Hello, I recently wrote an article about adding authentication to a React application. You can see the draft here. It uses Redux and OAuth 2, and I wanted to make an accompanying video of me actually stepping through the code in the sample app that I linked to. It's on GitHub, so you can try it out yourself, but I thought I would go through it. It's based on Ember-Simple-Auth, and there's a bunch more details in the article about why I did this. Anyways, let's go check out the app. So here we have the app on the left, the dev tools on the right, and I'm just gonna basically explain the app and how it works. So here we have three different pages: home, app, docs. We're on actually the login page, and you see if I click home, apps, or docs, I can't get there because those are considered protected, and these are being rejected by the connected router redirects from the React Auth wrappers I mentioned in the article. And you see it's storing the intended page I want, so once I do log in, I'll get redirected there, which is nice that they have built-in support for that. And now the first thing I'm going to do is kind of go through the entire login flow, show you the whole thing, how it works, and then we'll go step through it. That way you kind of know what to expect when I'm stepping through. So go ahead and click sign in. See, it opens up Microsoft's login page. It already kind of knows my user, so it skipped me having to enter my username. I'll click sign in. You can see it's redirecting here. It actually paused on that page intentionally because I have a standard 2-second or a 2-second delay in there just for debugging, because I need to be able to have enough time to open up the dev tools while that window's open. So you see, since the last route I attempted to go through was docs, it redirected us directly to docs as opposed to, say, the homepage. Now, there's nothing really on these things. They're just a dummy app, right? I have some sample Redux stuff that works, and the more important one is the homepage. When you click load profile, it's actually going to make a request to the Graph API and use the access token we acquired when we signed in, which kind of proves that all of this stuff works together. So we can actually go to the network tab, click load profile, and you can see it made the request out to the Graph API, and the bearer token is in the authorization header. And this is, just the raw stringified JSON. So now we'll go through the sign out flow. You see one of the links was hidden when I was unauthenticated. It detected I was authenticated, showed it, and go to the profile page. You can click log out, and this redirects us to the sign in page and removes the session. Now this is the bug I mentioned in the article, where it's supposed to have the query parameter linking back to our app or redirecting back to it, and so it should go back to the login page. For some reason it's not working, so we'll manually redirect back there, and you see we're back at the login page. We have completely signed out. Now this time I'll go to the sources tab and enable all of the breakpoints I've tried to pre-configure at the steps that are most noteworthy. So this time when we click login, we're going to stop at the click handler. Now this call that's highlighted right here is the one I called out in the articles being the one that I consider the most significant. It's extremely powerful and simple that all of this is abstracted behind one awaitable call. So you see we have the service. Probably should have named this auth service or something, but it is the React-Simple-Auth. Note this file is just locally part of the project. It would probably become an npm package that would be its own module. And then you give it the provider you want to log in as. I only had one, so I just kind of hard-coded it here, but perhaps you have a picker or something. Anyways, that's something you can decide. Anyways, we'll step into this and look at what this is happening. So here we're constructing the unique request key that's going to be used for the child window to communicate back up to the parent, because they both know this piece of information about where to store information. So we'll just step through here. So have to excuse me. There's a known issue in Chrome where when you use TypeScript's generic methods that end up leaving these angle brackets and types in the source maps combined with interpolated or template strings, it gets confused and doesn't terminate the template string, so it thinks this entire script is a string, even though stepping still works, thankfully. So anyways, it constructed the request key, and it constructed some window options. It asked the Microsoft provider to build a URL. You can, well, I guess we can't hover over it. Nope, there it is. And it's, oh, sorry, my phone is going off. Here it's about to open the window, but before it does that, I want to call out this check window function, because this one's also pretty important. So you see we're defining the function, and we're saying if the window's not closed, it's going to schedule to call itself again. So basically we're going to invoke it once. So it's going to continually keep calling itself every 100 milliseconds until the window's closed, in which case this will not be invoked, and it will continue on, execute all of this, and finally resolve the promise you see here with the session. And that's what makes the awaitable call. So click F8 to continue. We'll hurry in. We'll open up DevTools on this other window. Click sign in. We'll authenticate on my phone here. So you see, I put a debugger statement in this special page too. You can see the access tokens in the URL, and the name of the window is that unique key, so it's able to write the URL, which has all the important information. It either could have been an error or it could have been a success, in which case it has, for the Microsoft provider, it has not only the access token but the ID token, because it uses the new OpenID Connect standard. And we don't care anything about the URL. We just say take it and put it in location and let the actual application decide what to do with it. So this page is extremely simple. So it just closes itself, and you see we've gotten out of this kind of infinite loop. I suppose you could add some extra logic to say, hey, if you've been looping for over 5 minutes, just stop and say it was too long, but it's a little bit out of the scope for this demo. So here we get the redirect URL from the storage, and then we don't need that storage anymore, so we delete it. There is a case here where the user could have closed the window, in which case it never would have made it to our redirect page, and that storage location would have been empty. So we have to account for that possible error. So we say, hey, the login window was closed by the user, or perhaps authentication never completed, or some network error, right? Continue on. Now there is the possibility that, say, the user authenticated and there's something wrong with the secure token service, and it maybe had an outage and it just returned an error, or something else is wrong in your app, misconfigured. It'll actually return an error query parameter. And each provider, actually this might be an OAuth standard, so maybe error and error underscore description are two standard parameters, but either way we need the provider to extract that. So we'll ask it to return an error. If it may return undefined, in which case there will be no problem. So we continue. You see it's undefined in our case. And then the provider has the opportunity to extract any pieces of information it deems noteworthy about the URL. And we're kind of calling that a session object. That's probably not the best of words, but in our case, we have an ID token and a access token. In most cases, these are going to be JWT tokens, JWT. And so in my case, I take the ID token and actually decode it, and that allows me to get the user's their ID and their name, which is the most important pieces for a session. And this, I'll actually add another breakpoint here in the extract session method, and I can show you this. We're just using some simple regular expressions to extract out these particular pieces of information. You can see the decoded ID token has all the different claims that AAD provides. I guess these are pretty standard, but has like my tenant ID. Let's see, it was issued by Microsoft Online, which is AAD, has a specific audience, which I believe, is the Graph API or something else. Oh, this is the ID token, so that's not an API. The access token will have more important information. Anyways, we return this entire object as a session, and then we set that new session as local storage again. And then we finally return the entire request. And here, this is that async call has finally completed. We have our session object. It's stored in the application's local storage. And now we're in like normal React land. So that whole process was one call. And now you could operate as if login was an entirely synchronous process, right? You just call your login function here, which is a action dispatcher. You can see it's going into there. Eventually we'll get to our user reducer, and it's basically just going to toggle this boolean and set the user's name. So now that has forced the global state re-render, and pass all the way down, and our routes got reevaluated and we are redirected to the home page. So that is basically the login. And as I mentioned in the article, there's a couple other scenarios which are important for these. Let's see, which other two do I want to go over? Oh yeah, restoring the session. We'll go over that one first. So what happened? So I just logged in, and it took me possibly to enter my username and password, get my phone, do all that. You don't want the user to keep doing that often. So if I refresh the page, so let me put this breakpoint back here. Good thing I caught that. Okay, you'll notice if I go in the Chrome's application view, you see the session object we put in here. This is what we're going to look at to know we've already authenticated. So I'll go ahead and basically kind of hard refresh the app here. So the entire application's reloaded. Now, I mentioned this in the article. This is not the best of designs, but basically when the app is loaded, it's going to run this user reducer module to get the initial state. And because both of these services are stateless, they're just a collection of functions. We just ask it to restore the session using Microsoft's provider. So as I mentioned in the article, let's put a breakpoint here. The service is responsible for knowing where the session is, how to abstract away the storage mechanism, and the provider is just specifically kind of a wrapper around the specific provider's implementation of OAuth and their query parameters, their claims, their errors, all that stuff. So as you see here, the service gets it out of local storage. It knows where it was stored. It parses it, because you can only store strings back into, or deserializes into a strongly typed session object, and then it gives it to the provider. So that's how these two work together. And in the validation here, you can probably do some more complicated logic. I'm doing some perhaps naive things here and basically saying if the token still has, otherwise, what is it here? It still has more than 15 minutes left before it expires. Let's assume that's good enough for my app. Probably you want to do something longer, or maybe you could say, anyways, this token's unexpired and it has 15 minutes. So we're going to assume this is valid. In that case, we return the session because it was still usable. If it wasn't valid, we would remove the session from local storage and return undefined, which would effectively mean the user is not logged in. Anyway, so we'll continue here, and you can see we didn't have to sign in again, and we're already back at the home page. So that's restoring the session. So what's the next scenario we want to go over? Making an async request. So I demoed this with the Graph API, but now we're going to kind of debug how that happens. So similarly to the login, let's go to the click handle of the load profile button. So we have our home page. So I guess I can't quite see if Control B may work on the cursor there. Let's go ahead and put one in the reducer just in case. Okay. So in this case, I actually use Redux Thunk here. And so fetch profile is going to be invoked when you click the button. I'm not quite sure if my breakpoint's going to get hit, so I'll put one here. So go ahead and click load profile. Not too familiar with Redux Thunk, but basically it just adds some more logic to inject the dispatch argument to our function, and allows you to return a promise as opposed to just the action with the type itself. And so here again, we're taking advantage of the fact that these services, the React service and the provider, can just be imported and used anywhere. That actually maybe, you may say, I'd rather do dependency injection, and there are some issues where you probably want to know if you have multiple providers, which one they used, but kind of disregarding that, I assume that problem can be solved. So here we are, we're going to dispatch the kind of initial action. Doesn't really do anything. Going to make the request here. But in order to do that, we need the access token. So we just ask the service to get the token. And as I mentioned in the article, there's some weird stuff I put in here where you're passing a second parameter, which is the resource you want the token for. And this is a Microsoft specific thing I was playing around for. You can pretty much ignore it, and we'll just assume that that issue doesn't exist for all the other ones. If you're interested in more, you can. I wrote a big paragraph on what the scenario is for Microsoft there. Anyways, it's very similar to a restore session. The service goes and gets the session out of storage, passes it to the provider. And the provider here, I only actually use one resource, so I only ever have one token. We return it, and then the fetch request gets constructed. And eventually the server responds, and we dispatch the receive profile action, which goes to our profile reducer and sets it on the global state as the current profile. Oh, I finally hit this. Okay. And then we render the JSON. Let's see, anything else that's noteworthy to debug? We can debug sign out. It's not as impressive, but surely worth it. So add a breakpoint to the profile page. So here I'm clicking logout. Again, logout is the action creator that's going to go to the user reducer and just invoke the invalidate session method. And all this really does is destroy the session. So put a breakpoint here. You see it's just going to remove the session from local storage because the user is explicitly saying, like, I don't want this anymore. But there's also other things that happen when you sign out, and it redirects to this URL given to the provider. So this is going to go one step further and actually say, even if that token was somehow compromised, it should be invalidated by going here. So that's kind of an extra measure I mentioned in the article. Then if we go back to the app, see here it's trying to restore the session. Actually good. We can debug in that, and you can see what I mentioned where it takes the other path here. Did I skip it? Let me check that one more time. Restore session. Perhaps the breakpoints are a little messed up here. be validate session. Huh. Let's try. I mean, obviously it invalidated. You can see I was put to the login page, but it would be nice to show you there. Oh, that's why. It only is going to get to the validate session if there was an accession and it was expired. Because I explicitly deleted it, it's just terminating earlier. So right here, the session doesn't exist. So that's why I never got to the validate session call. That makes sense. All right, well, I think that's all for the video. Hope you guys enjoyed it. Let me know what you think in the comments. See ya.